What divided Newton and Leibniz went beyond math. The clash between Isaac Newton and Gottfried Wilhelm Leibniz is often framed around a simple question of priority: who invented calculus first? While this mathematical dispute generated decades of acrimony, it was merely the tip of the iceberg. Beneath the surface lay a profound divergence in worldviews, shaped by contrasting philosophies of nature, theology, and human understanding. The rift between Newton and Leibniz went far beyond mathematics. It revealed two competing visions of reality itself. A clash of temperaments and traditions. Newton and Leibniz were born into different intellectual environments. Newton, an Englishman, operated in a culture heavily influenced by empirical observation, Puritan religiosity, and alchemical traditions. Leibniz, a German polymath, was deeply rooted in the rationalist tradition of continental Europe and steeped in the optimism of Enlightenment humanism. Newton believed in uncovering the workings of the universe through observation and mathematical description, but his work was often suffused with mysticism. His private writings reveal an intense interest in alchemy, biblical prophecy, and the nature of the divine. He viewed the universe as a vast, orderly machine created and sustained by God, an idea that matched his belief in determinism but also his notion that divine intervention might occasionally be necessary to maintain cosmic order. Leibniz, by contrast, saw the universe as a manifestation of rational design, operating under pre-established harmony. He proposed that everything that exists is composed of monads, simple, indivisible, and metaphysical units that reflect the universe from their perspectives. These monads do not interact with one another causally. Instead, they are synchronized by God in a grand design, much like perfectly aligned clocks. This vision was grounded in reason and optimism, implying that we live in the best of all possible worlds, a phrase for which Leibniz is both celebrated and mocked. Determinism and divine intervention. At the core of their metaphysical divide was a disagreement about how the universe functioned and God's role in it. Newton's model of the cosmos was mechanistic but required divine intervention to remain stable. In his system, planetary orbits, for example, needed occasional adjustments by God to prevent long-term collapse due to perturbations. Newton thus saw God not only as a creator but also as a constant tinkerer. Leibniz found this notion deeply problematic. If God were perfect, Leibniz argued, then his creation should also be perfect, requiring no corrections. The idea that God would need to intervene to maintain his creation suggested a flaw in the original design. To Leibniz, Newton's theology bordered on blasphemy, portraying a deity who lacked foresight or power. Their theological disagreements bled into their views on determinism. Newton's universe, while mathematically precise, left room for divine will to act. Leibniz's universe, by contrast, was entirely predetermined from the outset. God's omniscience and rational planning guaranteed that all events unfold logically and necessarily. Thus, while both upheld deterministic models, Newton allowed for divine disruption, while Leibniz insisted on an unbroken, rational order. Optics and the nature of light. Their philosophical divergence also found expression in scientific debates, such as their theories of optics. Newton famously conducted experiments with prisms and proposed that light is composed of particles, or corpuscles. He used this model to explain reflection, refraction, and color in his groundbreaking work Optics. Newton's approach was experimental, grounded in empirical observations. Leibniz, meanwhile, leaned toward a wave theory of light, influenced by Christian Huygens. He was skeptical of Newton's corpuscular theory, believing that light could be better understood through metaphysical principles and rational analysis. Although the wave-particle debate would not be resolved until centuries later with the advent of quantum mechanics, the disagreement reflected their broader epistemological split. Newton prioritized empirical results, while Leibniz favored deductive reasoning from first principles. The calculus controversy is a philosophical symbol. The infamous calculus controversy, where both claimed to be the first inventor of differential and integral calculus, was not merely an academic spat. It symbolized the broader antagonism between their intellectual legacies. Newton developed his method of fluxions in the mid-1660s but delayed publication. Leibniz, working independently, published his results first in the 1680s, using a superior notation still in use today. When the Royal Society, dominated by Newton's allies, accused Leibniz of plagiarism, it led to an international fallout. Letters, treatises, and accusations flew back and forth. Newton, increasingly paranoid and secretive, orchestrated a campaign to discredit Leibniz, even writing the committee's final report under a pseudonym. But this quarrel was more than ego or nationalism. For Newton, mathematics was a tool for probing the divine architecture of reality. For Leibniz, mathematics was an extension of logic and metaphysics, a way of uncovering necessary truths. Their dispute over calculus thus mirrored their competing worldviews. Newton's empiricism, grounded in experiment and infused with mysticism, against Leibniz's rationalism, fueled by logic and theological optimism. Legacy and impact. The Newton-Leibniz divide had lasting consequences. In Britain, Newton's dominance led to an isolation of British mathematics from continental developments. British mathematicians clung to Newton's fluxional notation for nearly a century, hampering their integration with the broader European mathematical community, which embraced Leibnizian calculus. Philosophically, Newton's approach laid the groundwork for classical mechanics and the scientific method as we know it. His universe was one of forces and trajectories, described with precision and tested by observation. Leibniz's ideas, though less influential in physics, had a profound impact on philosophy and logic. His vision of a rational, interconnected cosmos inspired thinkers from Kant to Gödel, and his concept of binary arithmetic prefigured the digital age. Two visions of reality. The schism between Newton and Leibniz was not just a scholarly feud but a fundamental divergence in how to understand the world. Newton, the alchemist physicist, believed in uncovering God's laws through mathematical observation, even if it meant God had to step in now and then. Leibniz, the philosopher-mathematician, envisioned a cosmos so perfectly ordered that divine intervention was unnecessary after creation. As we've seen, the clash between Newton and Leibniz was never just about who invented calculus first. It was a battle of minds, of worldviews, and of how we choose to understand the universe itself. Newton's mystical empiricism and Leibniz's rational optimism continue to shape science and philosophy to this day. So, what do you think? Is the universe a finely tuned machine needing divine guidance, or a perfectly programmed reality unfolding on its own? Let us know your thoughts in the comments below. If you enjoyed this deep dive into history, science, and philosophy, don't forget to like, share, and subscribe. And hit that notification bell so you never miss an episode. Thanks for watching, and until next time, keep questioning everything.